Good morning, everyone. Devesh, you should mute yourself. Okay, so you can write anything in your chat box, but I have muted all of you. So is it audible? Devesh, is it audible? Okay. So let us start. So today I am going to take the classes on fuel of IC engine. Okay, so whatever how much I have completed, let me tell you, I have completed Breton cycles and their analysis and their performances, and the introduction to IC engine, that means the internal combustion engine, and I have completed also the analysis and the problems on the cycles, that is several cycles, there is auto cycle and diesel cycle, spark ignition, combustion engine cycle. So today I will start a new chapter, that is IC engine fuels. Okay, so let us start. Okay. So it is visible to all of you now. Okay. So this is the IC engine fuel. Myself, Sumon Ghosh, Assistant Professor, Department of Mechanical Engineering, CITM Boeing. So before going to the fuel, let me give you some introduction to the fuel. What is fuel actually is? So fuel is that ingredient which help us to get some energy. Actually, you know from the energy conservation principle that energy neither be created nor be destroyed. Only it can convert from one form to another form. So if you have any problem, before starting this, let me tell you, if you have any problem regarding listening or regarding this viewing of this, you can raise your hand and write it in your chat box. Okay. Okay. So as I was saying that energy neither be created and not be destroyed. That means energy can convert from one form to another form. Okay. So, and we know that world runs on this mechanical energy, most probably on electrical energy, and then we need to get this energy and we cannot create this energy. So what we have to do, we have to convert some kind of energy to this mechanical energy or electrical energy or whatever it is. And for this conversion, we need some ingredients, and that is known as fuel. So what happens in fuels, basically, the chemical energy of the fuel is converted into the mechanical energy by some processes. I think maybe one step, either it may be 4 step or 5 step, whatever it is, or it may be some bypass energy conversion. Okay, so by burning the fuel, we get some heat energy, and that heat energy, rather some portion or using some devices, is being converted into the mechanical energy or electrical energy by means of some devices. So today we will learn about this fuel. So basically there are 3 types of fuels. One is solid, another is liquid, and another is gas. Okay. So what is solid fuel? So let me give you one example. The example of solid fuel is coal. Liquid fuel, you know, that is a petrol, diesel, and gaseous fuel is your CNG, LPG, and your natural gases, methane. All these things are comes in the category of gaseous fuel. Okay. So as we are learning IC engine, so we will find out what is the suitable type of fuel for our IC engine or to run the Otto cycle or diesel cycle. Okay, so as we know that basically we use liquid fuel, that means the petrol or the diesel that comes under the category of liquid, and sometimes we use the CNG, compressed natural gases. Okay, but why we don't use solid fuels and gaseous fuel, let us see. So what is the problem regarding the solid fuel? The main problem of the solid fuel is its movement. So now suppose we want to burn the fuel and we have to carry the solid fuel from one portion to another portion. So it is quite difficult to move the solid fuel through a channel, and also its residual causes a great problem. After burning the coal, suppose the solid fuel is a coal, the coal leaves ashes, and it is very much difficult to remove the ashes. So we don't use solid fuel in petrol engine or your Otto cycle or your diesel cycle. Okay, and next problem is for gaseous fuel. Though gaseous fuel has tendency to make a homogeneous mixing, which will start our engine very easily and the distribution will be very much easy, but still the main problem of gaseous fuel is its storage, because gas has much more volume than liquid fuel, right? So the storage is a great problem for gaseous fuel, because we know that Otto cycle and diesel cycle, that is our cars and our buses, runs on the roads and it has a smaller volume. So it needs a higher amount of fuel to run to the long distances, and to run through these long distances, higher amount of space required for storage of this gaseous fuel. That's why the gaseous fuel is not used. So what the main things that is suitable for IC engine, that is your liquid fuel. So liquid fuel, you know, that is the petroleum, diesel, and all the other fuel that is comes under the category of alcohol. It comes under the category of liquid fuel. Okay. So let us see the chemical composition and the suitable fuels that are used in IC engines. So first comes the groups. Actually, I will tell you the groups one by one. First group is paraffins or the alkenes. The chemical formula is CnH2n plus 2. N can be any arbitrary number. It can be 1, it can be 2, it can be 3, it can be 4, and so on. So this fuel or the alkenes are chain, saturated, and stable. Okay. So one example I have given, that is butane. You know one alkyne group fuel, that is methane. What is the chemical name of methane? You can write it in a comment box. The chemical composition of methane. Okay, so let me tell you, that is CH4, where C is 1. Sorry, where N is 1. Now put N as 1. So if I put N as 1 on this equation, so it will come C1 plus H2 plus 2. That means 4. So it will come CH4. Now the example I have given, that is butane. Butane has a number of N is 4. That means it has 4 number of carbons. So the H will be 10 as per the formula. So it will be C4H10. Next category is alkenes. The chemical formula is CnH2n. What is the characteristics of this alkenes or olefin group? That is chain, unsaturated, and unstable. Though these alkenes group are chain, but you must remember this is unsaturated and unstable. So two examples are given. One is monoolefin, another is diolefin. So olefins can be categorized into two portions. One is monoolefin, another is diolefin. So first option for monoolefin is hexene. So hexene has N of 6. So if I put the N as 6 on the formula, it will come CnC6H12. Okay, so you can see the bonding and the chemical structure of this hexane. Now this diolefin has a changes in the formula. So you can write down or note down the formula for diolefin. The formula for diolefin is CnH2n minus 2. You can write it down. Cn, it is not written in this PPT. So you have to write it down. It is CnH2n minus 2. Okay. So butadiene is the example of diolefin. Okay. So butadiene has a number of carbon 4. That means N is 4. Now put the 4 on the formula and we'll get a formula of C4H6. C4H6. So where is H6? Tell you. So that is 1C, 2C, 3C, and 4C. That I have told you that N is 4 for diolefin, but H will be 6. 1H, 2H, 3, 4, 5, and 6. Clear? So let us move on to the next category. That is naphthene. Naphthene, though it is have the same formula like olefins, but it is a chain cycle, or it is a cyclic or cyclanes. The formula is same as olefins, that is CnH2n. Okay, it is ring, saturated, and stable. Okay, so you have to remember the characteristics of all these fuels. If it is a naphthene, then it should be ring structure, it is saturated, and it is stable. Okay, so it is written in this ring, saturated, and stable. So one example is given, that is cyclohexane. Cyclohexane, look at over there, it is same formula like hexene, C6H12, but the structure is different. The structure is different. The structure is cyclic, it is ringed or saturated and stable. So it has number of carbon 6 and number of hydrogen is 12. Okay. So the last category is the aromatic. It is the benzene derivative. Okay, the formula is CnH2n minus 6. CnH2n minus 6. It is ring and unsaturated. It is ring and unsaturated. So how the name comes aromatic? The name aromatic comes from the term aroma. You know the aroma means scent or odor. So it has some certain odor. That's why the name is given, this category is given as aromatic compounds. It is mostly benzene derivative. So you know that benzene has a formula of C6 and H6. Okay, so that means the number of carbon is 6. So if we put 6 in this N, so it will come C6H12 minus 6. That means H6. So the formula of benzene is given as C6H6. It is aromatic compound and the structure is ringed. You can see the structure is ringed. Okay. So next, let us come to the desirable characteristics of the fuel. That means there are several fuels available in this world. That is coal, your petrol, your alcohol, your diesel, and so many, hydrogen, natural gases, all these things. But what should be the desirable characteristics that will help us for the homogeneous running of the engine, that is the Otto cycle and diesel cycle? So if we use the fuel in the Otto cycle or the diesel cycle, that is the IC engine cycles, they must have these characteristics. So the main characteristics of the fuel should be the volatility. Actually, what you need in IC engine, Okay, before going to that, let me tell you what is the definition of volatility. The volatility of the fuel means the tendency of a fuel to vaporize. The volatility of the fuel means the tendency of a fuel to vaporize. So, what we need actually in IC engine? Actually, in IC engine, we need a mixture of air fuel. It may be homogeneous, it may be heterogeneous, and this mixture should be in the vapor form, right? And if it is in vapor form, the mixture is homogeneous, and our tendency in this IC engine fuel, it should be has a tend to make the mixture. That means when the fuel and the air mixes with itself, it makes a mixture, and the main desirable things for this mixture, it should be homogeneous. So if the fuel vaporizes more, then it has a tendency to make the mixture homogeneous, but it has some certain limitation. So one graph has been shown, that is the temperature versus the volume of the fuel evaporated. So you can see the graph. So along the y-axis, the temperature is given, and along the x-axis is the percentage of the volume evaporated. So we need this basically. So you can see on the upper portion, it is given that the front portion, the mid portion, and the tail end portion. So I'll tell you one by one what is the advantage and the disadvantage of the these three portions. So first come to the front portion. Its volatility is less. Its volatility is less. So as I have told you that we need to increase the volatility for the homogeneous mixture of the fuel. So the low volatile fuel is not desirable for the IC engine fuels. That's why we cannot take this front portion fuels, that is who has the low volatility. Next comes to the tail end. Then I will go to the mid portion, because mid portion is suitable. That means that fuels which comes under the category of this mid portions, so it is suitable for IC engine fuels. These are not too suitable for IC engine fuels. The tail end is very much important. That means the fuel is very much vaporizing. That means almost most of the particle of the fuel is vaporizing. But what is the main problem? Because we need it, because we need that the fuel should vaporize as much as possible. But everything, whatever is beyond our limitation, is not desirable. Whether it is fuel, whether it is our characteristics, whatever it is, we have some limitations. So what is the main problem if the fuel volatiles more? The main problem is if the fuel volatiles more, that means it has higher amount in the mixture, and we know that we need a lubrication in the engine for its homogeneous running and its smooth running between the cylinder and the piston. So we need it. But if the fuel has high volatility, it will mixes more in the air, and it will mix homogeneously in the mixture. So whenever this mixture goes to that portion, that is a contact portion of your piston and the cylinder surfaces where the lubrication stays, it will dilute the lubrication. So if the lubrication is diluted, then it loses property of lubrication. That means the friction will be more between the piston and the cylinder surfaces that in contact with the piston, right? So if the surfaces will be more, so it will affect the efficiency, it will increase the friction, it will lower down the lifetime of the piston and the cylinder. That's why the high vaporization of the fuel is not required. So what is required? It is the 20 to 80% of the fuel vaporization. That is for the smooth running and for the prevention of the higher friction. That is required. This the fuel should volatile between the 20 to 80%. Okay. So next characteristic is starting and warm up. So it is very much important, that is a starting and warm up characteristics of the fuel. Okay. So why it is required? So whenever the engine is starting, that means we have starting the engine for the first time of the day. That means it is at the room temperature. The whole night it has been cooled and it is right now in the room temperature. So if the fluid or if the fuel is not volatile, that means enough so that it can go to the fuel, it go to the cylinder and it can run the engine smoothly, it will not be easy for the engine to start. That means the fuel must have to volatile in the room temperature so that the engine can start smoothly. Clear? But what happens whenever the engine starts? So as the engine starts warming up. That means the temperature of the engine is increasing. So it should remain its volatility at the higher temperature also. And whenever the engine is warming up, it should be volatile enough so that the engine can run smoothly. Next is operating range performance. It is very much important in the characteristic of the fuel, because the manufacturer makes the engine or makes the fuel makes the engine that it can run from a lower temperature to higher temperature. Suppose I am in your Darjeeling. Not right now, I cannot stay in Darjeeling because I cannot move out of the room. But suppose we are in Darjeeling and my car, which is running in this Bardhaman or in this Boichi, that must have to run on the Darjeeling, where the temperature is average temperature is much lesser than our Bardhaman temperature or Boichi temperature. That means the engine fuel must have to perform, or it must have the volatility to make the mixture so that it can run smoothly on Darjeeling as well as in Boichi. Clear? Okay. So it must have an operating range so that it can be easily volatile and it can easily run the engine smoothly at different variations of temperatures. So next is crankcase dilution that I was talking earlier. The crankcase dilution. It is very much important. So if the fuel vaporizes more and it come inside the cylinder, because it must have to come inside the cylinder to perform or to complete the cycle, because the fuel will burn inside the cylinder and it will produce the power, the necessary power to run the engine so that the vehicle can move. But if more fuel comes, that means if the volatility more, that means the vaporization is more, that means more fuel comes inside the cylinder, that may not burn. That may not burn because we have a air fuel ratio. That means certain amount of air can burn a certain amount of fuel, not beyond that. It is 15:1. That is fuel air ratio. That is 15:1. There is 15 amount of air can burn one amount of fuel but one amount of oxygen. That is the air fuel ratio. Right? That means we have some certain limitation. So if we supply 2 amount of oxygen or 3 amount of oxygen, so it will be excess. Right? So and we don't need that excess oxygen or excess. So if the excess oxygen is required, then excess fuel is required, but we cannot supply the excess fuel. Right? So it is the loss of the fuel as well as the crankcase dilution. So if we supply excess amount of the fuel, that means the vaporization is more, then what will happen? It will go to the passage where the lubrication is there. That means the passage between the piston surface and the cylinder surfaces. So if it goes to the piston surfaces, that surfaces where the lubrication is there, it will try to dilute the lubrication. So the lubrication loses its property. So if the lubrication loses its property, there will be some frictions. The friction between the surfaces of the cylinder and the piston. So if the friction is there, there will be frictional loss. Okay. So I have 10 minutes left. Okay, so let me complete it fast. So the friction will be more. As the friction will be more, the power will be less and the efficiency will be less. Next thing is vapor lock characteristics. Vapor lock characteristics means that if the fuel has high rate of vaporization, that it may clog the carburetor metering or it may clog the fuel channel. So if the fuel channel is clogged, that means the fuel will not come in the cylinder or it will not be able to properly mix with the mixture. So our efficiency will be less and our engine will run short of fuel. That is known as the vapor lock characteristic. That is not desirable for any fuel for IC engines. Next is anti-knock quality. So you are well aware of this anti-knock. What is knock? First, let us understand this. I will tell you elaborately whenever I will tell you the combustion and combustion faults and combustion procedures. Okay, so I will tell you take the classes of combustion, then I will tell these things elaborately. But let me tell you briefly what is knock. Knock means the abnormal combustions of the fuel. So if the abnormal combustions of the fuel is there, that means there will be some unwanted sounds. Okay, and it depends mainly on the fuel. So the fuel must have to limit this knocking tendency. That means it has some characteristics of anti-knock. Okay, because knocking affects the in excess energy release, excess temperature, and the thermal efficiencies. Okay, so who is doing that? Don't do that. Don't do that. Don't do that. Next is gum deposit. What is gum deposit? Gum deposit means the fuels are the hydrocarbon, and as their chemical properties like the hydrocarbon, so that means they have a tendency to oxidize the storage and put some liquid or solid gummy substances which may clog the manifolds, the intake manifolds of the exhaust manifolds or the piston rings. That means if these folds are clogged by means of this gummy deposit, that means their natural performance will be less. That means their efficiency will be less. Okay, so that means the fuel must have a tendency to minimize these gummy substances, because we cannot control this, but it must have the tendency to make this as low as possible, these gummy substances. And the last one is the sulfur content. So most of the fuel has some sulfur content. So what is the effect of this sulfur content? If the sulfur is in the fuel, so it has some chances of corrosions of the fuel lines, the carburetors, and the injection systems, as well as the fuel has the lower ignition temperature, self-ignition temperature. Basically, self-ignition temperature means at that temperature where the fuel will self-ignite itself. Already I have told you, the self-ignition means the fuel will self-ignite it without any external resources. In SI engine, we need external resources, that is the spark plug, which help us to ignite the fuel. But whereas in compression ignition engine, that is the diesel engine, we don't need any external agent to ignite. It will ignite by itself by increasing the temperature. That means the temperature is so high that it can be so high that the fuel is self-igniting itself, right? So as the sulfur content is there, that means it is acting as that agent, that external agent, which help us to ignite the fuel, though it is required. But if in a spark ignition engine the ignition happens before the ignition timing, then it has a tendency to knock. So it will promote the knock. So we should prefer a low sulfur content in the engine fuels. Okay, so that's all about the characteristics of the fuel. So next day I'll start from the crude oil fuels. So this is the sulfur content. Okay. With this I will end this section. Okay, so I will start from the crude oil section and the refineries and the characteristics of the other fuels, the ratings and the numbers on the next lecture. I hope you have enjoyed this, and we will upload this video on YouTube, and we will give you the link on your WhatsApp group within 2 or 3 days after this lecture, and you can go through this lecture once again, and then you have queries, then you can put it on the comment box. Okay, thank you. Stay safe and stay home. Okay, so you have any questions, then you can raise your hands. Okay, I'm unmuting all. Okay. So I think you don't have any questions, so I'm leaving this. So I hope all of you enjoyed this session. Okay, session. So I'm leaving this session. Okay, thank you.
Hello.